Okay, good morning, everybody. Welcome on in. Excuse me. For starters, did I hear someone say they had a question? Was there a question that someone wanted to ask? No, we're good. Okay, thought I heard someone saying they had a question. You're welcome to bring questions to these sessions. That's actually a great idea because, as I've mentioned, we only have about 40% of the class meetings that we would have if we were on ground. So by bringing questions, then I can make sure I'm answering the things that you have the most questions about, that people need the most help with. So feel free to bring those questions in. You can always even email me ahead of time and I can kind of prepare a little discussion about that problem on the homework or whatever it is you need help with. Or feel free to bring it to class and we can just kind of answer that question on the fly as well. Okay? So looking things over, it looks like nearly everyone has signed up for the homework. That's great. And almost all of you have 100% on the first assignment. So that's great. The homework is set up in a way where you can basically get, you should be able to get almost 100% on the homework because it keeps letting you work on it. It's not like if you get it wrong, the points count against you and then you don't get to work on that anymore. So, that's one way to do well in the class, is have that strong homework grade by, just keep working through it. And it looks like a lot of you are. Many of you have completed, I saw some people with hundreds on the first 3 assignments. Some people have done the first assignment. That's good. As long as you're keeping up and not getting behind, that's great work. And if you have any questions along the way, feel free to ask. And let's move that over there. Feel free to ask, and we can, answer those questions. Otherwise, I don't see anyone asking any questions. I don't see any hands up, so I'll move ahead. But, like always, if a question comes up, feel free to ask or put it in chat or whatever. It's better than, what you don't want to do is be afraid to ask a question because you're kind of shy about it, and then this question lingers for weeks, either how the class works or material or anything like that. And then, it's much better to just get it out of the way now. No one's going to think you're silly because you asked a question or anything like that. So don't worry about that, okay? All right, then if there's no questions on how the class works, here we go. So let's see. So there's a question here about the homework. So I think it should help your score. So the way it works is each homework is composed of a number of different topics, and it varies from homework to homework, right? So some homework assignments might have 3 topics you have to master. So I'll try to explain that. So if you have some homework assignments might have like 8 or 9 topics that you need to cover by the end of that homework, and some might have like 3. But for most of those topics, and sometimes I adjust them. If a homework assignment gets way too long, I'll adjust it so that it, if I assign a bunch of topics to a homework and it says it's going to take it basically, whenever someone does a homework problem, the data is recorded. There's all sorts of data. Whenever you do something on the online homework, that data is recorded. So basically, when I create a homework assignment, Delta Math will predict on average how long it's going to take people to complete that assignment. If I create an assignment and it says it's going to take students 3 hours to complete that assignment, that's kind of long. So what I'll do is I'll cut it down. So instead of getting 5 points on each topic, you might need to get 2 or 3, depending on what the topic is. The default is 5. So the way it works for each particular topic in an assignment, like the default, this varies, but the default is you have to get 5 points on that topic. Basically, you need to get 5 right. So you have to earn 5 points on that topic to move to the next topic. Okay. Now, if you get one wrong, you lose a point. But if you get one right, you gain a point. So in other words, if you get one right and then you get one wrong, you get one right, you get one wrong, you get one right, you get one wrong, you'll never complete that topic. You need to get up to where you have 5 points for that topic. So in other words, if you get one wrong, you're going to have to get one right just to get back to where you were, and then you can start moving ahead. This is why it's really important A lot of students don't like to check their work, especially in other homework assignments or platforms. Students go, well, it's going to tell me if I got it wrong or right. Here, it's in your best interest to check your work before you put it in the computer, because getting it wrong, there's actually like a deduction for it that you then have to gain back those points. And that's actually good, right? It's not a form of punishment that, oh, I want you all to have to go through this. That's how you do mathematics in real life, is you check your work, right? People who do mathematics, people who are, mathematicians, people who do research, you always have to check your work, because in real life, there's no way to know if your work is correct or not when you finish it. And what you don't want to do is move ahead with incorrect research, with bad calculations, or turn something into your boss that has bad calculations and then you look bad at work. It's always a good practice. You want to be checking your work when you finish something. So that is something that is definitely helpful, the way this homework is organized. When you finish a problem, just double check it. Look it over. Usually checking your answer is much easier than finding the answer, right? Like if you solve an equation, it should only take a very short period of time to check that you got the right answer. It will be significantly shorter than finding the answer. So that's kind of how it works, is if you get one wrong, you kind of have to get one right to get back to the same point total. And then as you get them right, it should bump you on to the next topic. Okay. So I know it's a little confusing because some of you may have been used to using my Math Lab or WebAssign, and those work a little bit different. This mechanic is actually really good for students. So yeah, so if there's any other questions, feel free to ask those, but that was a good question. Okay, so I will move ahead roughly with where we left off. You might hear me say a few things that are, repeats of what I said last time, but most of it will be moving ahead into new territory so that we're progressing through the chapter. And the chapter is largely about linear equations. Okay. Now, keep in mind, too, not every single thing I say in class will have a homework assignment with it, and not every homework assignment will be something that I covered in class. But if you watch the videos that are in Canvas, it all should be covered, right? So one way or another, all that material is getting explained to you in one place or another. So we've got, oh, this isn't going to work. I'm going to have to do, let's see. Let's do this. There we go. That looks pretty good. Okay. So linear equations. So a linear equation is a pretty basic setup for a type of equation that gives us a line when we graph it. Okay. And remember, there's this really helpful website, Desmos, that most teachers use now. In fact, let me move this down a little. Desmos, you can see it at the top there. DESMOS.com. Desmos is a really convenient graphing utility. They call it a graphing calculator, which it's kind of weak on the calculations part, although it does do some impressive stuff. But it's really a graphing utility. If you ever need to graph something, the easiest way is just go to Desmos, graph it. It's free, so it's available to you while you're kind of checking this stuff out. Again, please use it as a learning tool, not something to just do your homework for you, right? Or to kind of try to speed through your homework, because then you're not really going to know what it is and you're going to have trouble down the road. Right. So when we graph a linear equation, it should look like a line, right? A straight line, something like that. We know what that's supposed to look like. That's a straight line. So that equation, actually, maybe I should show this over here. Y equals 2x minus 1. That's a linear equation. Now, what you want to realize is we have multiple ways of expressing the same equation, right? So, for instance, you can see here I have y equals 2x minus 1. What if I wrote this as y plus 1 equals 2x? Notice I get the same exact line, but those things are written differently. Well, that's because we can use our algebra tools to manipulate that and put it in a different form, but it still represents the same line. Okay, you can see it. They're right on top of each other there. So what we do in mathematics is sometimes we take an equation that's in one form and we do algebra on it to put it in a different form. Usually we're putting it in the form of y equals mx plus b, which you may or may or may not remember or have seen before. That's okay. But that's the most general form. It's called slope-intercept form, and I'll go over it in just a second in case you've kind of forgotten or haven't seen it before. But there are numerous versions, right? We could write it this way. We could write this as negative 2x plus y equals -1. Notice that's now a third way to write this line. It's the same line, but it's written in a different form. This form right here is what is oftentimes called standard form. Okay, so we have slope-intercept form. We have standard form. We also have another form, which we could do, let's see, y minus 1 equals 2 times x minus 1. Notice now we have even another way. We've now found a fourth way to write this same line. And this one, if you can see it there, is called point slope form. And we name them after the thing that it's about, right? We don't usually name stuff at this level after like a person's name or something like that. Point slope form has the information embedded in it for the slope and a point. We'll get into that in a little bit here. But you can look, by looking at it in this form, you can figure out the slope of the equation of the line and a point that line is on. Up here in the original here that's in slope-intercept form, it gives you the y-intercept and it gives you the slope of it. So depending on what form, like you can go through and you can calculate the slope using slope formula, but if we just do some algebra and get the line in the right form, you can just get the slope. You don't have to work as hard in order to get it. And as far as vocabulary, remember what the y-intercept is? This axis right here, this line, that's the y-intercept, or sorry, that's the y-axis. And wherever your line crosses the y-axis, that's called the intercept. So right here, this crosses at 0, -1. Right, so that point that's showing on the screen right now, 0, -1, that would be our y-intercept for this line that we have graphed, because that's where it's crossing the y-axis. Okay, now why is that so important? I think a lot of students just go through and go, I know how to figure that out because my teacher told me, but like, why would I? Well, who cares? The y-intercept and x-intercepts actually end up being very important, right? And I see this not really emphasized a lot of times, and students just think, oh, I just have to memorize how to do this. The x-intercepts and y-intercepts are actually very valuable information to know about a graph that you're graphing. The y-intercept is oftentimes the initial condition for a problem. Not always, but very oftentimes it is. Like if you open a bank account and it has, or in some type of investment account, and it has money in it that's changing over time, well, the value right here, right at the y-intercept, that's going to be your initial amount. That's whatever your account started with. So even though that information may not be given to you in the problem, you can figure it out by realizing, oh, that's my initial condition, right? An initial condition, initial means starting, and condition just means the state of things. So what state did my bank account start in? Oh, it started with this balance right here, right? And then you can go from there. The x-intercepts, we'll be talking about this entire semester. You'll be working on those. Those are oftentimes the solutions to the equation you're trying to solve, actually, right? It's a visual representation of what you're trying to solve there. Okay, so let's see. Right, okay, so let's go in and break down some of those different forms because it's important that you know those. Let's see. So let's move this back here. So we have the slope-intercept form. Slope-intercept form is your basic form. If you're ever not sure what form to put your line in, put it in slope-intercept form. I mean, I would go so far as to say, unless a problem specifically tells you to put it in some other form, it should be in this one. This is the most useful one. It's the easiest one to work with. It's usually relatively easy to solve for. You want to put it in that form. And you've probably heard this or remember y equals mx plus b. That's that form. Okay, y equals mx plus b form. So let's go, for example, y equals 3x plus 5, right? That would be an example of that form. Basically, you have y solved for, and then everything else is on the right, and you have the x component first, and then you have a number, right? This is super useful because if I give you this and say, tell me what the slope is, you don't have to calculate anything. You can just look at it and say, the slope is my coefficient on the x. It's 3, or 3 over 1, right? In fact, let me throw a fraction in here just so we can deal with the more complicated case. Let's do it. Oh, sorry, I used the wrong slash. There we go. Okay, so in this case, if I gave you this and said, what's the slope? You don't have to calculate anything using slope formula or anything. You just look at it and say, oh, the slope is 2/3. I can tell because that's the coefficient on the x. And if I said, what's the y-intercept? You'd say 0.5. And that one's even easier to see because remember, if you're on the y-intercept, that means your x value is 0, which means if we plug 0 in for x, we would get y equals 5, giving us the 0.05. So this is helpful because this means that the slope is m and the y intercept is, might run out of room here, let's see. Zero B. Okay, so you can just grab the numbers from the problem. Notice I didn't have to calculate anything. All I have to do is look at it. That's why it's such a convenient form. I just look at it and say, oh, yep, there's the slope, there's the y-intercept, and that's all you need to graph it. If you know like let's say we wanted to graph this, y equals 2/3 x plus 5. Let's go back and graph that now. So if I graph y equals 2/3 x plus 5, and let's say I haven't graphed it yet, I would go to 0, 5, and I would graph that point. Right, I would graph that point. So see how I've got my point at 0, 5. And then I would use the slope, which is 2/3. Remember, it's rise over run. So that means I'm going to go up 2 over 3. So that gives me my next point. So that's going to be what, 3, 7? So then I would graph that point, 3, 7. And when I draw the line through it, sure enough, I get the line y equals 2/3 x plus 5. Right? So there we go. We've got our line graphed. So it's real easy and straightforward to graph a line when it's in that slope-intercept form. It's also easy to get the most important information, which is the slope and the intercept. Okay? So generally, that's the default. Now, we teach in these algebra classes different forms of the line, but what you want to realize, I think some students miss this because we teach you so many different forms, you can actually do any problem using just slope-intercept form. Right? There are certain problems that some people say is easier if you use point-slope form or something like that. I don't even think it's easier, but we generally are supposed to teach point-slope form as well, and standard form and all these different forms. To me, it's actually kind of confusing when we can just get away with one form. But just be aware we do have these other forms that we need to be aware of as well. Right, so let me go to a new page here. We'll start fresh on a new page. So the next one that comes up a lot is called point slope form. And this one looks like y minus y1 equals m times x minus x1. And I know a lot of times in mathematics, actually for a lot of people, the hardest thing to do is to learn the new notation. I know that's where a lot of people get hung up, is on notation, and they get confused with notation, and it's totally reasonable. So if you're someone who gets confused by the new notation, that's okay. What you want to do is pause and really focus on that notation until you learn what it means, and then move ahead, because it's very hard to learn the notation and the mathematics at the same time. Okay, and you'll hear people say, well, math is a language. That's part of it. Part of math is a language because we use a whole different notation and we have specific definitions, but math is so much bigger than that. It's not like if you just learn the notation, you're good to go. You also have to know the concepts. So there's kind of two things you're learning at once. You're learning the language of mathematics. You're also trying to learn the mathematics itself. So see these subscript 1s we have on here? All that indicates is that that's from a point, right? So we're saying, here we have an x, that's a variable. Here we have a y, that's a variable. So it might be reasonable to think, well, is this x sub 1 and y sub 1, are those variables? No, they are not. They're standing for a specific thing. So we say where m is the slope and x sub 1, y sub 1 is a point on the graph. So in other words, it can be any point any point on the graph, right? So since there's an infinite number of points on the graph, you have an infinite number of different choices to plug in here, and that's kind of a strength and a weakness, right? It's nice that any point you happen to know you can use to find the equation of your line. The problem is everyone in the classroom could come up with a different representation for that line. Now that tends to lead to confusion if you're ever working in a group, and I don't even mean in class. I mean if you're working in a group at your job where you have to use some math or some research or something that you're doing. If different people are using different forms of this equation, it leads to mistakes. So we usually do not like to leave our answer in point slope form, but it can be helpful for finding the equation of a line. I still would rather use I still use slope intercept form myself in all situations, but some students kind of learn the way I do it, where you always use slope intercept. Some students like to use the point slope form. There isn't a right or wrong way to do it. If you're getting to the right answer and it makes sense to you, that's the way that you should use. Okay? So let me give you an example of how we would do this. So let's say we have a problem that says find the equation of the line with slope. Let's make it 2/5 that passes through the point let's go 5, 5. Okay, so find the equation of the line with slope 2/5 that passes through the point 5, 5. Let's see, how could I do that? Well, first of all, I highly recommend this anytime you ever do a math problem and you're using a specific form or formula or something like that. Just write it. That formula is your guide through the problem. It only takes a couple seconds to write it out, and writing it out usually means you're actually going to move through the problem quicker, right? It's that whole go slow to go fast. So I'm going to write out our form that we're using, which is y minus y1 equals m times x minus x1. Oops, it's not going to let me scroll anymore. Let's see. Let's go down to a new page and do next page. There we go. Now I can move it up. Okay, so now what I'm going to do, I have the form that I want to work with. Now I'm going to go through and take the information from the problem and plug it into my form here. So what do I know from reading this equation? Well, here's my slope. The slope is 2/5. And remember, when we're dealing with lines, m is the slope. Okay, so I know I'm going to turn this m into a 2/5. And then right here, this point, that's my x1, y1. So in other words, this x value from this point, that's my x1. The y1 from my point, that's my second coordinate here. So to fill this in, we would get y minus 5 equals 2/5 times x minus 5. So I've taken the two 5s. This 5 became the x1 because it's the x value. This 5 became the y1 because it's the y value. And the 2/5 from the problem became my 2/5. Now technically we have found the equation of the line that passes through that point and has that slope. But we almost never want to leave our problem in this form unless we are specifically told to. So what I would want to do now is put it in slope-intercept form. Okay, that's always the default unless you're told to do otherwise. Put it in slope-intercept form. So now I'm going to have to go through and figure out, okay, what's the math going to look like here? Okay, there's a good question here, and I'll get to that in just a moment. Let's see. Yep, I'll answer that question in just a second. There's a question about slope, so I'll cover that. So to finish this one, what we want to do is, well, let's see. Let's distribute that 2/5, right? So this will become y minus 5, and notice I'm only doing one operation at a time. You don't want to multitask when you're doing math. The chance of you making a mistake goes up in quite a bit unless you're really, really familiar with what you're doing. Your chance of mistakes goes up. Mistakes take a long time. So we're going to make this, this will become 2/5 x. And then it's, so 2/5 times negative 5. Remember, that's going to become negative 2. So this will become minus 2. If that doesn't sound familiar, you might brush up on your basic arithmetic with your fractions and integers, right? But the 5 in the denominator cancels with the 5 in the, with this 5 when we distribute. So it gives us this. And now we want to add the 5 over to the other side, which would give me y equals 2/5 x. If we're adding 5, that's going to give me a plus 3. And now I have my equation written in slope-intercept form, which is always our default. So let's take a look. Let's double check. Here's a good way to double check. Right, Desmos is helpful here. So y equals 2/5 x plus 3. We want it to go through the 0.55. So let's plot that. Good. That's good, right? That was a condition, is that our line was supposed to go through the 0.55. It looks like it does. So that's good. And just to double check here, let's put it in this form up here. So y minus 5 equals 2/5 x minus 5. Okay. So this would be y minus 5 equals 2/5 x minus 5. Oops. Oh, because it should be like this. I forgot my parentheses. See how those parentheses make a big difference when you forget them? So you can see those lines match up. If they match up, that means I didn't make a mistake from this step here, line number 2, to my 4th line. I didn't make a mistake there because these lines should all be equal to each other. And sure enough, when I graph them, they're all equal. They go through the point we needed it to go through, and we can double check the slope. Up to over 5, everything checks out. Everything's good. Okay. Now, I had a question. There was a question here with slope. So let's talk about that, because slope is super important. You can't really understand lines if you don't understand slope. So I'm glad that question was asked. Let's take a look here. Where are we? So our slope formula is that y2 minus y1 over x2 minus x1. Oops, that's not right. x2 minus x1. There we go. Give it a, oops, I did it in both of them. And actually, we usually write this as m equals, because when we're talking about lines, m is generally going to, 95% of the time, it's going to be your slope, right? So this, to find the slope, if you have 2 points, you plug them in here. So the question that was asked was, how do I know which one's y2 and which one's y1? And here's a good answer. As long as you're consistent, it doesn't matter. So I'm gonna show you how to calculate it, and we will actually see it'll come out the same both ways. So let's take 2 points. Let's take, say, 2, 1, and how about 5, 8? Okay, I want to find the slope of the line that goes through these 2 points. And a very good question was asked. How do I know which one is x1, y1, or x1, x1, y1, and which one is x2, y2? As long as you're consistent, it doesn't matter. So what I oftentimes do is I'll write on my paper just to remind myself which one I'm assigning. So let's assign it this way first. We'll do x1, comma, y1, and x2, y2. And we need a dollar sign there. Okay, so it doesn't line up perfectly, but you can see how I'm labeling this. My x1 is 2, my y1 is 1, my x2 is 5, my y2 is 8. So now if I plug it into this formula here, let's steal this code right here. In fact, I'll just take the whole line. Now I'm just going to plug those values in using the assignment we just made. So my y2 is 8, and my y1 is 1, and my x2 is 5, and my x1 is 2, and if I look at that, it looks like I'm going to get what? 8 minus 1 is 7, 5 minus 2 is 3, so it looks like our slope here is 7/3. Okay. Now let's say I did it the other way. Let's say I had decided that 5, 8 should be x1, y1, and 2, 1 should be x2, y2, right? So watch what happens. Let's just change this part. So I make this x2, y2, x1, y1. So as soon as it compiles here, see how I've switched the assignments? Now my x2 is 2, my y2 is 1, my x1 is 5, and my y1 is 8. It's still going to come out properly when I do this. So let's see. I'll just take that and change this to be 1 minus 8 and 2 minus 5. And you might think, how on earth is it going to come out to be the same if I'm changing the order of the numbers? Well, look what happens. This becomes -7 over -3 now. But we know that a negative over a negative, that's really division of negatives, and those negatives cancel, making it again 7/3. I can scroll up a little here. Yep, so now you can see it. We still get 7/3. So it doesn't matter how you label your points. It'll come out as long as you don't mix and match, okay? The way that this can go wrong is if you, like, say you call this x from one point, you call that x2, but then you call this y from another point, you call that y2, then yes, your numbers are going to come out wrong. That's not going to work. But as long as you're consistent with the labeling, your slope will be fine. Okay, so don't worry about that. Just label one of them x1, y1, label the other one x2, y2. Okay, so that should, if I understood the question, that'll answer your question for that one. Okay, yeah, so good question. Okay, so let's see, where were we? So we were talking about, yep, the slopes, point slope form. There's also standard form. Now this one comes up less often, but it does occasionally get used. Let me take this and put it here. Standard form. So your standard form just means you've got your variables on one side and your constant on the other. And this comes up, you'll see this a lot in the next chapter, right? You're actually going to see numerous forms of our lines next chapter when we talk about systems of linear equations. There are certain problems where you're going to want to put all your problems into standard form and do it that way. So it comes up, but you won't really have to stop and think about it. You'll just go, oh yeah, I need to get my variables on one side and my constant on the other. So this form is usually expressed the following way. AX plus BY equals C. That is, you have your X and Y variable on the left. You've got your coefficients in front of those variables. And then whatever your constant is, remember a constant is a thing that doesn't have a variable in it. Like the number 7. 7 doesn't vary. 7 always means 7. Whatever context we're talking about the number 7, it's always the number 7. Right? Whereas a variable can take on different values. So, for example, 2x plus 3y equals 6. This would be an example of something that is written in standard form. So 2x plus 3y equals 6. Basically, your variables on the left, things that aren't variables are on the right. So sometimes this can be used to conveniently find your intercepts, but it's easy enough to find your intercepts in the other form. Like I say, this form, while it does come up in this chapter, it really kind of shines in the next chapter. That's when it really becomes more useful, right, to anybody. And if you have questions, make sure you're throwing those in the chat there, and we can deal with it. Make sure I click the right thing here. Where are my graphs? Introduction to functions. We talked a little bit about functions last time, and then graphs of functions. So let's kind of give a brief introduction to some functions. So the definition of a function sounds very confusing. It basically says that for each input, you have exactly one output. And that, when you think of it in that abstract context, it's kind of hard to make sense of it, and you go, why would I even care about that? But it actually makes a lot of sense, right? Because an input, you can think of that as a question, and an output, you can think of it as an answer. So when you ask somebody a question, how many answers do you want? You generally want one answer, right? If 5 of you ask me what the date of the exam is going to be, you would probably not feel good if I gave 5 different answers, right? You would want me to give the same answer every single time you ask me. Every time a student asks me, when's the first exam, and I give the same date, that you're going to feel better about that than if every time a student asks me when the first exam is, I have a different answer for you. That would be unsettling, right? So that's ultimately what a function wants. It wants, when you ask it the same question, so one input, you get the same answer each time, one output. Okay. And then there's a question about 2.1. Okay, we can take a look at that as well. Right. So where am I? Right. So for functions, that means that we can write it one way. So you'll see it written out where they say, let me delete this. So they'll have say, I think the confusion that people run into with functions is that we have lots of different ways of representing functions. We can represent a function in function notation. where the f of x takes the place of the y value. So for instance, this is a function, y equals 2x minus 3. We can consider that equation a function, but usually, a lot of times we like to write that in functional form. So we would replace that y with an f of x, and we would write this as f of x equals 2x minus 3. Those represent the same thing. They are two different ways of writing the same thing. What we did here was we replaced y with f of x. But that shouldn't be a capital. That should be like that. That's all we did there, right? We replaced the y with f of x. It behaves the same way. There are certain, and I know this throws people off sometimes because, a lot of students are like, just give me the problem and I can memorize it and then I'll get them right on the test. But with functions, we use the function version that is most convenient. So sometimes you're going to see, like when we find inverses in college algebra, it's more convenient to have it in equation form. When you're just trying to graph some points, it's more convenient sometimes to have it in function form, depending on what you're doing. So, I think students get frustrated where they're like, just tell me the form I should be using. Well, it depends on the problem that you're working on as to which form is most convenient and going to make the problem the easiest to deal with, right, to go through. So there's those two forms. There's also the graph form, right? We can look at the graph and say, all right, if we've got y equals 2x minus 3, whoops, how did that happen? Minus 3. What happened here? Oh, because I don't have an equals, I've got a minus there. There we go. Y equals 2x minus 3. This line, that's a representation of that function, but it's a graphical representation of the function. What you need to be able to do is look at any of these forms, the graph version, the algebra versions. You need to be able to look at any of those, the equation form, the function form, the graph form, and try to get the same information. Now, sometimes that's harder to do than others, but sometimes you don't have a choice, right? There's some problems that are easier to do with function form, but you may not have it written in a function form, especially if we're dealing with a piecewise function. You just might have the graph. Someone gave you the graph, and you have to figure out your information by looking at the graph. And that can be challenging for some people. So it's not one of these situations where we go, yeah, there's 3 or 4 ways of writing functions. You just learn the one you're most comfortable with. It's more like you got to learn all 4 of them. And so that can be, I know that can be a little overwhelming and confusing for people. So you definitely want to look at that. But the more you graph things, like those of you who are going on to college algebra, pre-calculus, something like that, you're going to spend a lot of times going back and forth between the algebra and the graph. We do that so much in that next class. If you're going the route of either one of those classes, you're always bouncing back and forth between the algebra and the graph, and you have to be comfortable with that. In statistics, we do that a little bit, but it's more about being able to graph the line successfully and be able to plot your points, draw the line that goes through them, and then be content with that. Okay, and then there was a question about 2.1. Is there a specific question I can answer about 2.1? Oh, maybe that person wants to talk to me after class. So we can take a look at that. So let's see, we're kind of running out of time here. So I'll give some time here to answer questions. So I'll stick around. So in just a moment, I'm going to close down the YouTube stream. I'll stay in Zoom and answer questions for people. And then remember, today's Monday. So today's the day where basically when I'm done here, I go to school, and then I have my office hours on campus. So if anyone wants to come to my office and ask me questions there, you're welcome to do that. Okay, you can come do that. Okay, so yep, thanks everybody. Let me close this down. Come ask me questions in Zoom if you have any, and then the person who asked me about 2.1, I'll take a